So the attendance is very less today. Am I audible?
Yes, ma'am, you're audible.
Okay, okay. Okay, let's start with today's session. Let the others join shortly. Okay, so today I'll be discussing with you the week 7 assignments of the previous run course. So in the present week, in the pre-recorded lectures, you might have seen about logistic regression, how you can implement this logistic regression in R, and maybe you have worked with one of the data sets. So I hope you have practiced with some data sets that is available with you. I mean that is given with you. So in the previous run course, the assignment was given with the and it was solved with the help of iris dataset. So I don't know if that's the dataset given to you right now, but today's examples I'll be telling you with the help of the iris dataset. Okay, so we'll move on to the first question. So the question was like, load the dataset iris.csv as a data frame, iris underscore data, with the first column as index headers. Okay, so the first column they want as index headers, first row as column headers, dependent variable as factor variable, and answer the following questions. So I'll just go and show you what the iris dataset looks like. Okay, iris dataset, CSV. So it's available everywhere. So this is like what it looks like. Okay, so sepal length, sepal width, petal width, and variety. Okay, so this is what the data set looks like. So the downloaded data set which is available to you is this one. Okay, yeah. So this is, it has an ID, sepal length, sepal width, petal width, and species. Okay, so this is the data set given that was given to you, given to the students and participants. So okay, we'll move on to the rest of the things. So the iris data set, okay, if it's not visible, I will, yeah, I think it's visible now. So it contains 4 sepal and petal features. These are the features: sepal length, sepal width, petal length, and petal width. Okay, all in centimeters, of 50 equal samples of 3 different species. Okay, so 3 different species, 50 samples of Setosa, 50 samples of versicolor, and 50 virginica. So so I'll move on to the Python R implementation together with this. So I'll move on to the R Studio. Okay, so just I'll clear everything. Okay, yeah. So okay, so let this be there. Okay, so we have to load this first. That is given in the question. Okay, so the question is given like, load iris.csv as a data frame. So the first thing I have to look at is what is my current working directory. So my current working directory is this one, and the file is also stored in that working directory itself. Okay, so there is no need to set the working directory. Otherwise, you should use the method like this one, like set wd. Okay, with using that you have to set your working directory. Okay, So right now it's not needed. It's correctly in the um, required folder only. So I'm not changing it. Or another thing is like if you want to load, you can give the directory here itself. This type of variation I had shown in last class. Okay. So first question is that what are the dimensions of the data frame? So what I'm doing is like iris.csv. I am reading into iris data and data frame known as iris data underscore data. Header I am giving as true. So since if I am giving like that, then the first column will be taken as the first row as the column header will be taken. Then row names equal to id. So we had seen, just wait. So this was the data set. id was the first column. Okay, 150 rows and 5 columns. Yes, yes, Kavita, that is right, 5 columns. But this particular thing has an extra column here known as id. Okay, then the usual thing has like this only, 5 columns only. Okay, features. So here what was told is like first column as the index header will be giving. Okay, so that means that we have to give the row dot name. We are naming the rows of the data frame using the id column, and strings as factors equal to true. We are looking at the categorical features. So here in this data set, the categorical thing is coming in the species only. The rest are numerical. Okay. And ID we are giving as the row name also. Okay. So if we run this one, I mean, if I'm storing iris and iris underscore data in this particular using this particular criteria, then it's loaded into iris underscore data. So if I view this, it's coming like this sepal length. So ID, the column ID, which was present in the data set like this, is converted to the row name. So it's coming like this. Then all the rest are there, right? Then, okay, so about 150 rows are there. Yes, so if you do the dimension, Kavita has already given the answer 150 rows and 5 columns. Okay, so that is the first answer. So you can use dim, that is the function to be used. Okay, now okay, so second question, we'll move on to the second question. So the answer is written there. You can just uh, watch that later. Yes, Ivan Dominic, it's available and it's present in the problem solving session tab. There is a link, and when you are checking on that link, you will be directed to a Google Sheet which contains all the links to the drive as well as the YouTube links. Okay. So the first answer is option A, right? Is everyone clear? We'll move on to the next one. Okay, what can you comment on the distribution of independent variables in the data frame? Okay, so how can we see this one? Do you have any idea? What can you comment on the distribution of independent variables in the data frame? So, what are the independent variables in this data frame? From this particular features, what are the independent and what are the dependent feature? Yes, Kavita, you can do that. Yeah. So you see that these are the input variables. Yes, the input variables like sepal length, sepal width, petal length, petal width. These are the independent features. And the species, Setosa, versicolor, virginica. Yeah, that is the dependent variables. So For finding out how is the distribution, you can do a pair plot. Okay, that is possible. Or you can do a summary itself and see. Okay, so just look at the options here. First option is like all the variables are normally distributed. The variable sepal length and sepal width are not normally distributed. The variable pattern length alone is normally distributed. None of the above. Okay, so these are the questions. These are the options. So there is some problem in those options, like I have given it as it has been given in the previous run course. Okay, so to find it out, one option is like you can do the summary of the iris data. Okay, so right now we have stored the data frame iris underscore data. Yes, and if you do a summary, you will be getting this. Okay, so the summary right now shows like this. Can you tell me how to see if it's normally distributed from the summary? Any idea? Okay, so one method is to look at your median and mean. Okay, so what you mean by normal distribution? So this normal distribution is like, for example, if you have a particular sets of data. Okay, some data you are having some numerical data, and if your whole distribution of the data is following a bell-shaped curve with mean is equal to 0 and standard deviation like plus sigma minus sigma, like that it's going, you can tell that it's normally distributed. Okay, so for some normally distributed, if your particular thing is normally distributed, that it mean implies that your mean will be like similar to the median of the distribution. Okay, that is one of the things you can see. Okay, so in this particular case, when you see the summary, you can check here. So the first sepal length, it's like 5.800 and mean is 5.843. So anyway, you can tell that it's kind of normally distributed. Okay. Next one, sepal width. That is also like 3.05000, 3.057. Okay, some variation is there, but still it's kind of, I mean, skewness means like it, whether it is like going to one of the I mean side of the distribution. Is it if it's right skewed or left skewed? Okay, but it's kind of like similar. It's 3.0. It's coming. The variation is coming in the second decimal point. So, okay, we can say somewhat. Then the next one, petal length. It's like median and mean are showing different a lot of variation. Okay. Next one is like median and mean, some differences. So okay, it's like kind of some differences are there. So let's go back to our options. Okay, so first option is that all the variables are normally distributed. When you look at this summary, you can see that this is not particularly the case. Okay, yeah, it's not very skewed. It's kind of normal, but still, it's. I mean, these values are not that much. Okay, so then another thing is like, I mean, and the next thing, that next option is like variables sepal length and sepal width are not distributed. So the one or two things that we have found that is normally distributed is sepal length and sepal width. So the second option is anyway incorrect. Then the variable petal length alone is normally distributed. Petal length, median, and mean are showing very much variation. So that option is also not correct. So ideally, you can go for the none of the above option, but the answer which is given. So this is like the summary, okay, and the answer that was given was all the variables were normally distributed. That was the given answer, but it's actually none of the above will be more correct. Okay. Now you have mentioned about pair plot. That is also, yeah, it's a fine thing. So just I'll copy the thing actually. So for that you need some um, thing actually. Okay, so I'll just give you how the pair plot also looks like. It needs some library. Okay, that library also I will just install. Mm, so if that is included, if that library is included, and if you plot, okay, this is your, okay, if you can see, I think I'll yeah, so it's like this is the image. Okay, so here you can see that it's kind of coming, sepal length is kind of distributed, and some part of a bell-shaped curve is coming in sepal length. Okay, so this is like a pair plot, what you have said, Kavita. So sepal length is like autocorrelation, like that it will be coming. Okay, and other correlations are given like sepal width and sepal length correlation is this much, sepal length and petal length. So this is a normal pair plot. So here you can see these two, yeah, kind of normal distributed, but the petal length, it's having, its distribution is showing a different shape. Okay, and petal width also it's different. Okay, so you can't say that everything is normally distributed. It's kind of a shaped curves are coming, but there are two dips and, okay, so it's not rightly normally distributed. Okay, so there is some skewness. Okay, is it all right for everyone, that question? If it's all right, I'll move on to the next one. Okay, so that is the second one. Now next question, how many rows in the data set contain missing values? So how do you find that? I'll just increase the size. Okay, how many rows contain missing values? Kavita, of which one is correct? None of the option is correct. Are you telling about the earlier one? Yeah, none of the above. Yeah.
Previous question.
Yes, yes. Okay. Yeah. For second question, none of the above that is the answer. The answer that was given was already was anomaly distributed. Okay. But that was wrong. That is wrong. Okay. So the fourth one is right. Now, how many rows in the data set contain missing values? How do you find that? Hmm? So, anyway, this is for distribution. This is like can be observed with pair plot also. Okay, pair plot. So for that, you have to install the libraries that are shown. Okay, install packages with that. Okay, so Kavita, yeah, you have given. So the question 3 is how many rows in the dataset contain missing values? Just have to give is NA. Is NA is like missing value or null value. And sum of that is NA will give you. So if you give that, the answer is coming as 0. So that's the fourth option. Okay. Next question. What can be interpreted from the plot shown below? Okay, so this is a plot. Okay, sepal width versus sepal length. Okay, so some set of things are given, like sepal widths of versicolor flowers are lesser than 3. So I'll just move to the full screen since it's difficult for reading. So the first option given is like sepal widths of versicolor flowers are 3. Next is like sepal lengths of setos of flowers are lesser than 6. Sepal length of Virginica flowers are greater than 6, and sepals of setosa flowers are relatively more wider than versicolor. So can you give me the option for this one? Answer for this one. So you're just given the plot. From the plot, you have to find the interpretation. Okay. So the plot is between sepal length and sepal width, and all the three species are also given with the particular color coding. Okay, so just looking, I mean, this particular plot, it's you can see that in this particular data set, you can separate linearly only one of the option from the rest. Okay, like for example, setosa is clearly separated from virginica as well as versicolor, right? You can't use a simple line, straight line, to separate all the categories. Okay, you can separate between setosa and setosa from versicolor and virginica. Okay, but it's difficult to separate these two. That is one of the things that you can observe from this plot. Then another thing, sepal width of versicolor. Sepal width of versicolor is green. So they are telling like it's then lesser than 3 centimeter. Sepal width, is it lesser than 3? No, because two options here. Okay, blue color, sorry, versicolor. Here, the highest one, the largest versicolor having sepal width, it's more than 3. So the first option is wrong. Then the sepal length of setosa flowers are lesser than 6. So setosa, it's a red color. Sepal length, yes, sepal length, it's the 6 centimeter mark. It's left of the 6 centimeter mark. Okay, the 6 centimeter is coming here in this line. So yes, it is. Sepal length of setosa flowers are lesser than 6 centimeter. That is a right option. Then the next one, sepal length of virginica. So virginica is the blue one. Its sepal length um, are greater than 6. Okay, so virginica, blue color. There are points which are lesser than 6 also. So that can't be counted. And the fourth one, sepals of setosa flowers are relatively more wider than versicolor flowers. So setosa, versicolor, the sepal width, so it is more than versicolor. It can be observed from the graph. So these two options can be interpreted from the plot shown beside. Okay, so that is true. We'll move on to the next question. I hope this is clear. Now, so based on the given plot, can be seen that setosa flowers have wider sepals compared to versicolor and virginica. Also, sepal lengths of setosa flowers are less than 6 centimeter. Okay. Now, which of the following code blocks can be used to summarize the data? Fi- Finding the finding the mean of the columns, petal length and petal width, similar to the one given below. So our intention is to get our output like this: petal length, mean of the petal length as 3.758 and petal width as 1.199333. Okay, so this is what we have to get. And now we have to try all these options. So we'll try all these options one by one.
She's doing so fast, bro. I can't see only.
What? Can you repeat the question? Is it not visible? Okay, if it's not visible, please respond someone.
It's visible. Still, you can make a bigger screen.
Okay, okay. Mm, for the R Studio, you're telling?
Yeah, this is visible. In the previous questions you
Okay,
have
okay, okay.
shown.
Okay. Uh, this is visible now?
This is fine. This
Okay,
is
okay.
fine now.
Okay. So the question is like, which of the following code blocks can be used to summarize the data? Finding the mean of the columns, petal length and petal width, similar to the one given below. Okay. So this is the question. We have to arrive at this particular answer in R Studio. So we have to try all these things like L apply, S apply, apply. All these functions we have to try and see whether we get this particular answer. Okay. So everyone can try. So what I'll do is like, we'll try each one of the options. Okay. I'll move on to the R Studio. Okay. So this is the question 5. Okay. I've increased the size. So the option D. Option D was given like apply iris data, then all rows, and 3 to 4, 1, comma, mean. Okay. So apply is a function that you have seen earlier. It applies the given function to all the things, right? So apply, if you give, returns a vector or array or list of values obtained by applying a function to the margins of an array or matrix. So its syntax is like you have to first give the data, then margin, then function. Okay. So right now in the apply, what I've given is like the data. This is like iris data. Margin I have given as 1, which denotes like it will be calculated as row, and then mean. So this gives the mean value across the columns for each and every row in the data frame. Okay, since we have given us 1. So the D option is like this, and the answer will be coming like this. Okay, so like now, iris data 3 to 4 means like it is the petal length and petal width. So the mean of petal length and petal width for each row is calculated and given if we give like this. Okay, so iris data 3 to 4 means it is taken like petal length and petal width, and 1 denotes its row wise. I mean, like for each row, the mean will be calculated. Okay, so this is not the option. The option is wrong because we should get the mean for petal length as well as petal width in all the rows. Okay, so actually this option, if we had changed like so right now that option is not, option is present in another option. So right now if we give like this, we change it to 2 and then put apply, you'll be getting this 3.758 and 1.199. So that is option, it's already there. So I'll say that is option C. Okay, so option C is correct. Option C, if you do, it will give you the value which is given in the question. Okay, now we'll try for the other options. So right now from this value, we have found out that the D option is wrong. Okay, it's wrong. And if it's like the C option, okay, C option is right. Okay, now the next thing we will try with, yeah, Kavita, you have just put it like that. So it'll directly come, but in our options, we have given the margin also. Okay. So S apply, yeah. So S apply, what will S apply do? I'll just put it. So S apply, it returns It's a user-friendly function and wrapper of lapply. So these are different apply functions. Lapply will return a list of the same length as ax, each element of which result of applying function to the corresponding element of x. So here in apply we had to give the data, margin and function. Here it's like data, function. Okay. And then the other parameters are there. So if you do s apply and you give like this, okay, it's coming like error in match dot function. So there's a syntax error. Okay, actually in according to the syntax it should have been given like a data and function. So what you can change here is that you just remove the to here and just find it out. Okay, so now if you do, that is the correct, it is coming the same as apply. So this is the this is the correct syntax. Okay, so if you change it like that, the B option will also be true. Now let us look at the A option, which is L apply. You had already seen that. This will give you like this. Okay, L apply, petal length and petal width like this you will get. Okay, so the options which you can do is like you can go with the D option, C option, and you can go with the A option also. Okay, so in this case, you can just go with A as well as C. Okay, now it, so this is all the options I have given here. Option A, option C, what will you get? Okay, so everything is displayed. Now, which of the following packages must be imported to use the logistic regression function? This one. Okay, so you don't have to import any function for using logistic regression. It's an inbuilt function available in our program, so you don't have to use any of the above. Okay. Now, encode the dependent variable species. Split the given data set iris underscore data into training and test set in the ratio 7:3 and with the seed value as 1, 2, 3. So the thing is like first thing we have to encode. So the first thing is encoding, and the next thing is the splitting. We have, I mean, these are the steps that are given. Splitting into training and test set ratio with the ratio 7. I mean 7:3. That means like 70 in the training and 30 in the test set. And seed value is also given that we have to set. So apply the logistic regression model. Okay, logistic regression model. Okay, so this model we have to apply. And after applying that, we have to find out which of the following parameters are significant with 95% confidence interval. So what we can do is like, we'll go back to the R Studio and just we will look at the question. So again, once more, I'll load the iris data. Okay. So iris underscore data, read underscore CV, this one. Okay. This I'll load into the data frame iris underscore data. Now library CA2, so this have to be like loaded here. So if it's not there, you can just check if the package is available. So CA2s I have installed actually. Okay, so it's for different things actually. So you want to install it for seeing these different things. Okay, so anyway, it's installed in the system. So I'll just load that into the environment. So yes, I have loaded. Now, first, one of the things we had to do is that we had to set the seed so that to restrict the randomization. Okay, otherwise, each time we'll be running the program, you'll be getting different values. You'll be getting different predictions, different values. So, that randomization we have to restrict. So we are giving like set.seed equal to 123. Now, next thing is the splitting of the data. So split underscore data, I'm just giving equal to sample dot split. Okay. And how am I splitting? I'm splitting according to iris underscore data in the column species, which is the dependent column, and split ratio as I'm giving like 0.7. Okay. So it's stored in split data. So if you give like sample, this is sample and sample dot, if you give split, this is the syntax. Okay, split the data into test and train set. So you have to specify according to what split ratio. Okay, so that's we have given there and stored in sample split underscore data. And now we have splitted it. Okay, now so now it will be stored like split underscore data equal to true will be taken like one set of data, and split underscore data equal to false will be taken like the other set of data. Okay, so one will be the test data and the other will be train. So we are splitting the training and testing it and testing data and naming it to two different sets actually. So what we'll do is like we'll form a subset from iris underscore data, and in that, so right now if you look at iris underscore data, okay, this is this one, like that it is given. Okay, so from this one split data, okay, so split data will look, split underscore data will look like this. Okay, so split underscore data is like it will be having true false like that is going. Okay, so all the true sections we are giving as training and all the tests false we are giving as test. So how do you select that? We have to select the iris data. Okay, because from the iris data only we have split it. Okay, so we'll subset iris underscore data with the condition wherever split data equal to true, and then we'll see the dimension of the train underscore iris underscore data. So there were like 150, right? 150 entries were there. That 70 is to 30, so 70 percentage had gone here, so it's like one coming as 105, and the rest will be given to the test data, which is coming like this one. Okay, so we have split it into training and test data, and the next thing is like train underscore iris underscore data of species. So why we are doing is like we'll just okay, so I'll just, we've had to find out, the question was like we have to find out the parameters, the parameters are significant with 95 percentage confidence interval. So one of the method is like we can just train the model and we can find out the summary. Okay, so what I did is like I have just um, changed this one. Okay, so this particular like species right now it's like, if you see the test data is like this and train data is like this. Okay, just I close that. So you have to encode it. Okay, I move on to the other thing. So we'll just run this one. Okay, as numeric, converting into numeric. So then if you look at that, you can see that species have, it's converted as 1, 2 and 3. The test data also it's like 1, 2, 3. Okay, test and train, like this it is looking. Okay, so we have encoded it. Now, so till this we have done. Now what we'll do is like, so we have done the encoding, we have done the splitting, we have set the seed, and now we have to implement the model. So how to implement the model? This is the function glm. So the formula is like species, this is the dependent variable, and the independent variables are all the others. So you can give like a dot. Okay, you can give like a dot for getting everything else, or you can just specify the columns which are required. Okay, so if you do like that, and the data is from train underscore iris dot data, so you are saving this to logit underscore model, and if you see the summary, then you'll be getting it like this. Okay, so I'll just maximize this window. So here you can see that GLM formula species like this, data equal to train underscore iris underscore data, then residuals, then the things like intercept beta not, beta 1, beta 2, beta 3, beta 4. Okay, their significance levels. So right now you can see that there are 3 stars here according to the significance score point not 1. We are asked about 95 percentage confidence interval. That means that you have to look at point not 5. Okay, so 1 star here represents point not 5, right? Okay, so the question, which of the following parameters are significant with 95 percentage confidence interval? So in the R studio, just can you mention in the chat window from what we have seen here, what all things will be like having are significant with 95 percentage confidence interval? Okay, so petal length, yeah, it is surely like significant because it's coming like in this value. I mean, it's having this particular significance code. So it means that our present assumption, like hypothesis, is true. Okay, and this so beta naught, beta 1, beta 2, beta 3, this one for petal length is significant. Okay, but actually that is, yeah, Soundarya, you're right. Intercept petal length and petal width. Yeah, you're true. Yeah. So we are asked about 95 percentage, but still this other things, the intercept as well as petal width, they are having like the code 3 star or asterisk. Okay. So it means that, I mean, it's having like 99.9 and that much percentage confidence interval they are having, so that can also be included in that. Okay, so if you are asked for 95 percentage confidence interval, these are already anyway significant, with a higher confidence interval, and since it's mentioned as 95, you can include petal length also. So the answer will be coming here as all the 3. Okay, so I'll just return to the window and just mark. So intercept is significant. It's like you are getting 99 point that much. Petal length, and petal width. All these 3 are significant. Okay, so this is the data. This is how you can do B, C, and D. Okay. From the given summary of the model applied on the training data, it can be observed that the parameters petal width, petal length, and intercept are significant variables as the p-value are lesser than the confidence level. Okay, so we'll move on to the next question. So what is the coefficient of the variable sepal width in the fitted model? Okay, so we have to find the coefficient of the variable. So we can find this from the summary that we have taken, right? Summary of the model. So I'll just go back to that thing. Yeah, so here in the summary, you are asked about the variable sepal width coefficient. Okay, coefficient of the sepal width. So it's like this one. This is the coefficient of sepal width minus 0.3 minus 0.1311. Okay, so from that you can see the coefficient. Okay, so that is the answer, solution C. Okay. State whether the following statement is true or false. Logistic regression tends to overfit when we have a large number of independent variables present. Can you tell me the answer? Okay. Anyone else? I'm getting different answers. Okay. Anyone else? Okay, that is right. Okay. It tends to overfit when we have a large number of independent variables present. For example, for this particular question, when you had seen the summary, you have found out that intercept, petal length, as well as petal width are the significant things here, right? Others are non-significant. Okay. So if you are including all the others, it will tend to some kind of lead to overfitting. Okay. So you can do with the others itself. Okay. And so if the number of independent variables are high, the logistic regression tends to overfit. Okay, so that is true. Okay, Kavita, I think you understood. Yeah. Okay. Now, next question. So that was a ninth question, and then 10th. An ROC curve is plotted between. This is very easy one. Can you tell me the answer? Okay, B. Yeah, that is true. It's plotted between sensitivity and 1 minus specificity. Okay, I think you have learned about these parameters in your recorded videos. Okay. Yeah, so ROC curve can be plotted between sensitivity and 1 minus specificity, or it is also called as true positive rate and false positive rate, to determine the better classifier that accurately predicts the classes. Okay, so these were the 10 questions that were in the assignment. Now we'll move on to the practice questions. Okay, so the practice questions is like, which one of the following is called as the odds ratio? Can you tell me the answer? Which one of the following is called as the odds ratio? A, B, C, D. You can put in the chat window. You have learned about the odds ratio, right? Like P of x by 1 minus P of x. Okay. So anyway, I'll tell you the answer. So the answer is like ratio of probability of an event occurring to the probability of the event not occurring. Okay. Since you had like P of x by 1 minus P of x was given like the odds ratio. Okay. Yeah. So that is the first one. Next one, in confusion matrix, the misclassification rate. Okay. So what was accuracy? Okay, what was confusion matrix? First, the first diagonal, if it is like, what you say? That if the prediction is there and the true one is there, yeah, okay, then true positive, false positive, okay, false negative, true negative. Okay, yeah, but that is the confusion matrix. And what is the accuracy in this one? So the accuracy will be like, the diagonal things, true positive plus true negative. Yeah, by total number, yes. So what is misclassification rate? What are the misclassified things here? Misclassification rate. Okay. So the misclassified things here are, yes, that is right, false positive plus false negative by the total number of samples. Yeah. So false negative plus false positive by total number of samples. That is the misclassification rate. Next one, value of both sensitivity and specificity lies between. How have you seen the values of sensitivity and specificity? What is sensitivity? Okay, and D, yeah, that's right. What is sensitivity? Sensitivity. How many positive predictions that you have caught, right? Okay, so what is specificity? How many predictions, positive predictions that you have collected? Yes. So you can tell how many positives. So positives are given like true positives. I mean, the things which are positive in the true case are for true positive and false negative. So those are actually positive. Okay. And only true positives were correctly predicted as positive. So sensitivity is like true positive plus false negative, falsely predicted as negative. Okay. And the specificity is of the other thing. Specificity. Okay, specificity is like, what is specificity? Collect all the negative labels. Okay. So the negative labels, true negative. TN is the true negative label. Yeah, that is right. Shiva Krishna. So specificity is like true negative by true negative things are FP and TN. Okay. So that is why you have to give TN by TN plus false positive. So these are the true negative cases. In that true negative cases, you have correctly identified this much things as truly negative. In sensitivity, these are the positive cases, and in that you have um, taken this much things as positive, predicted this much things as positive. So that is sensitivity and specificity. Its values will be coming like 0 and 1, right? In between 0 and 1. Then the logistic regression, a linear relationship is assumed between the independent variables and the, tell me the answer. So logistic regression, you are assuming a linear relationship between what? The independent variables and what will be the option here? Okay, sigmoid is a function log. Okay, this is like a simple question. You don't have to go to the equation. Okay, I mean equation is like log of the probability like that is equal to beta naught plus beta 1x. That is like you're giving, but the question is like we are assuming there is a linear relationship between the independent variables and just the dependent variable. Okay, that is our assumption. We are assuming that our independent variables and dependent variables are linearly related. Okay, none of the above is the answer. Okay, even though we are like looking at these functions when we are finding it, we are just assuming that there is a linear relationship between independent variables and dependent variables. Okay, so the answer is none of the above. Okay, now the confusion matrix for a binary classifier gives, this is straight away answer I have already given. If these are the true class and these are the predicted class, then true positive, diagonals true negative, true positive, then this is like Pooja D, yeah, everyone is giving D. Yeah, then this is like false positive and false negative, right? So all these things are there. Now so these practice questions are also over. Let me move on to, so the answer is D. Okay. Now let me move on to some other kind of implementation. Okay, so I'll just show you a different kind of analysis. Okay, same thing, only using the same data set, but we'll just see. Okay, so we will just see how the different variables are um, how we can do the different analysis here. First, what we'll do is like we'll just analyze with two things. Okay, because here in this iris data set, we have seen from the initial plot, like for example, it's like having three categories: setosa, versicolor, and what was the other thing? Virginica. Okay, these three are there, but in your initial model, when we had plot, okay, I think it was here. Excuse me. Sorry. So initial plot, this was the initial plot, right? This is the distribution. So here you can see that separation is possible between setosa, versicolor, and virginica, right? So that is possible. Setosa can be separated. The others are kind of distributed together. Okay. So first, what we'll see that we'll just see for two of the cases first. Okay. So what I'll do is like I'll load the same data set. Okay. So in the question, we were asked to download the dataset and store it to iris underscore data. But the thing is, it's already available as a dataset in R itself. Okay. So first, I'll just clear everything, clear the environment, and okay, this also console also I'll clear. Okay. And what I'll do is like first I'll load the datasets. Okay. So then what you're getting is like library underscore library of datasets. If you are loading, all the datasets which are inbuilt here will be loaded, and it contains iris. Okay, that dataset is there. So you're loading this particular dataset into ir underscore data. Okay, so right now if you check that, you can see the same dataset is there with 150 observations. So it's already present in R. You don't have to download it from anywhere else. Okay. So can you tell me what will this function do? Head of IR data. Just a while. Just give me a moment. Yes, everyone's showing like the first 6 rows will be displayed. So you can see here the head underscore IR of data. Okay, if I run this one, we will see the first 6 samples. Okay, so the first 6 samples. So that is there. Now, what will structure of the data do? You can find the structure of the data. If you run this one, okay, just I'll maximize that level. So it's like data frame, sepal length, sepal width, petal length, petal width. All those are numerical, and the other one we have it's read as a factor, so it has 3 levels or 3 categories. Now, if you want to see the different classes, can just say like levels of IR data and dollar species, which will give that particular column. So the levels will be shown as setosa, versicolor, and virginica. Okay. Now, just some of the things which had already come up, like finding the null values. So there are no null values there or missing rows there. So it's like returning 0. So we have already seen. Now what we'll do is like we'll first choose two species, and then after that we'll go with selecting all the species and we'll do the analysis. So first we'll do the analysis with two species. Okay. So I'm giving like, I mean, this particular data is um, like it's marked like the first 50 observations will be setosa, next 50 observations will be versicolor, and then other next 50 will be virginica. Okay, it's arranged like that. So it's easy to split like that to consider two species. Like for example, if I'm giving 1 to 100, then I'll be getting the first two categories, setosa as well as versicolor in the data frame. Okay, so what I'm doing is like IR of data 1, excuse me, 1 to 100 in this one. Just I'm saving it like that, and I'm setting some random seed value like 100, and now I'm doing some simple sample. Okay, so last time we had done the sample like this. Okay, so we have split using, I mean, we have included this library, and then we have done a sample dot split using this particular thing and split ratio like that. That's also fine. Okay, you can do like that, or simply like you can just give like this sample of 1 to 100 like this 80. So this is like a simple splitting. It's not randomized, and it's not like selected from others. Okay, this one is a kind of a correct method of splitting. Like for example, we are splitting like this, and some values will be given as true, some will be given as false. Here what I'm doing is like in the 1 to 100 rows, the first 80 I'm taking as one sample. The next thing I'll be taking as the other test set. Okay, so this is one type. You can use the this method to split it nicely. Okay, so I mean, about the splitting and all, you might have already seen in the pre-recorded class, right? So IR underscore train, I'm giving up to this particular 80 value, and the others I'm putting as IR underscore test. So if you do the dimensions right now, there are only 100 observations, and in that 80 rows and 5 columns are coming in train, and the rest 20 and 5 columns are coming in the test. Okay, so this is one simple method of splitting. If you have installed this library CA2s, and if you're doing like this will be a more correct method of splitting. Okay, but if you have simply two rows and you can split like that, this is one of the methods. Okay, now then for plotting, this is like pair plot. If this packages, I mean, you can use this particular packages for pair doing a pair plot. So if these packages are not installed, then when you are checking with this program, just remove the comment and run these two lines. Okay, so it's already installed in my system. So what I'll do is like I'll include that in the environment, and then I'm doing a pair plot. So right now, remember that there are only two categories here. So if I run this thing particularly, I will be getting this one, right? So this, if I extend, okay, so it's coming like this. So you can see here, okay, just if I save this image in like two categories. Okay, got some particular thing, and if I load that to categories, so this is coming like this. Okay, like sepal wind correlation. Oh, this correlation has not come clearly. So anyway, we'll see once again. So if I do like this, okay, yeah. So right now, this is the sepal width and sepal length. Okay, so okay, this is the figure. So you can see here these values 0 to zero point 0.6 is coming up to like 1 only. This is kind of normalized. Screen is not in presenting mode. Can anyone else say? I mean, this is our studio, okay?
No, it is in presenting mode only.
Yes, okay, yeah. I hope this graph is visible, right?
Yes, yes.
So, yes, this plot we had seen earlier. So now, just now, we have only two species right now. Okay, setosa and versicolor. So for sepal length as well as sepal width, you can see here that this is kind of normalized curve, and when you look at here, yes, some outliers are there. Okay, and this is the distribution for sepal length for setosa as well as versicolor. Okay, now for the next one, sepal width, these are the distributions. The others are just shown like this. All the different correlations and the distributions are shown. Okay, so this is that plot. Now sepal length, you can see, just I'll minimize this one. So you can see here that sepal length is more normalized. So some outliers are there actually. Okay, so it's not, there are some outliers, so I can't say like that. So sepal length is more normalized. Okay, so what you can do is like so here some outliers are there. Okay, so what you can do is like, to get a clean data and which is not dependent on other things, we can just select the sepal length. That is enough actually. Okay, so to separate, since we have considered only two variations here, only setosa as well as versicolor, and you can see from the distribution that it is kind of distributed differently. If you consider just the sepal length itself, there is no overlapping in these two distributions, right? So you can just use that to see your to create your model. Okay, so now since I have seen this plot like this, what I'll be doing from this plot is that I'll be just forming the model with the y value, which is the dependent value. Just I'm naming it like an ir underscore train species to y, and ir underscore train dot sepal length. I'm just taking the sepal length here now. We'll see the result with that. Okay, so I'll be saving this as x and y values, and I'm using the GLM function, GL fit for logistic regression. So GLM, I am giving like family equal to binomial since we are doing a logistic regression, and then I'll be seeing the summary. So in the earlier case, when we had done the GLM, we had given like species as that is the same here right now. That is what we are doing here, but the x values we had given all the values, right? So this was that case. Now what we'll be doing is like we'll be just giving x value as the sepal length and we'll be seeing the summary. So if I do that, I am getting the summary like this. Okay, so there is just the intercept and just the sepal length. And right now when we are using these two only, significance is coming like point, so 99.99 like that percentage significance is there. So if you are using like 95 percentage confidence interval, then both these are significant for your analysis. So both can be used, and now you can predict with that. Okay, so I'm reminding you, like we have just looked at two things only, like two different categories only. Other categories are not present. So we'll see the result. Okay. So what I'll do is like I'll create a new data frame with IR test. So we have formed the model with the train values, and then we'll do like with IR test, we'll form a new data frame with just its sepal length. Okay. Now we'll see the predicted value. The predicted value will be given as predict. This is our function, logistic regression function. New data is the x value, since we are just considering sepal length now, and the type is response to find the probability. So I'll run that, and I'm forming a new data frame prediction which has IR test underscore sepal length as one x value. Sorry. So IR, this one is sepal length. Then IR test underscore species, that is the other thing, and then predicted value. So if I run this and see the prediction, okay, now it is coming like this. Okay, so it's coming like sepal length, one of the column, species, and the predicted value. So you here looking at this level, you can see that some are like 0.5, 1.2, 0.5, 0.83 are coming, right? And here some for versicolor mostly greater than 5 are present. Okay, I mean greater than 0.5 is coming like for versicolor. Okay, so in the recorded videos you had just seen like if it's given like a threshold, like if it's greater than zero point 0.5, you'll mention it as one particular type. If less than zero point 0.5, you'll mention it as other particular type. That particular operation we will do here also. So just I am forming like a new frame. Okay, print new. Okay, with data frame, sepal length, species, and predicted value. Okay, so this is the new frame. So if I do that new frame, if I see that new frame, thread underscore new. Okay, so this is looking like, this will look like this. This is the frame. Okay, now then I'm putting like thread new, predicted value like this. Thread type I'm putting is setosa, and if it's greater than 0.5, I'll be putting like this. Okay, so right now it's coming like this. Okay, so there are some misclassifications. You can see here species setosa, but it's predicted like versicolor. Then there are many misclassifications present here. Okay. So what we'll do is like we'll form another new data frame. Okay. And so what I'll do is like a new data frame, let new put the classification, then sepal length, species, and right now it's like thread new, then with this thing thread new, dollar predicted value. Okay. So with that, let me try, or okay, we will try with that and see what is coming. So thread underscore class will look like this one. Oh, sorry. So let me. Okay, wait a moment. Thread type, sorry, and I'll just do it like this. Underscore type. Okay. So if I do this particular thing, it's coming like this. So you can just see the species as well as the product type. Okay. Now what you can do is like, you can just see the confusion matrix and install this, and in the confusion matrix we will just see between, okay, the class. So this is like first column, second column, and third column. So all rows, third column, and this one, just put second column, and fuzzy color if you are giving, we'll see what has happened. Okay, so there is one problem coming, error in equal. Oh, some problem is happening. Can you tell me what is the error here? Have you looked at this thing? So just let me just see. Okay. So is there anyone can find out? Have you tried this confusion matrix, anyone? If I just give confusion matrix of red class, what we will see what will happen. Okay. So reference is missing. Okay. Okay. Oh yeah, reference I haven't given. So anyone trying with me? Confusion matrix. So the data we can give like red underscore class. This will try like this. Okay. Red underscore class of, so actually this should have come. Okay, we will see the next thing how it is looking like. Okay, so pride underscore class, I'll just give like this and see, we find out what is the problem in this particular statement. Okay, reference is missing with this is what actually you have tried in your recorded classes. Okay, so like that you try for this one and see. Anyway, I'll just show you the Q plot later. Okay, so the Q plot we will just see, this is like um, this particular plot is like this one. Okay, it's similar to the basic plot function. It can be used to create and combine easily different types of plots. So for the next class, you just see and tell me what is the error in that. Okay, I'll be uploading this thing. Okay. Now this one Q plot is like prediction 1, round prediction 3, and so prediction is right now this one. Okay, prediction is right now this one. It has like these values. So prediction I'm giving like this. Prediction of 1 is sepal length. Round prediction 3 will mean 1, 2, 3 predicted value. The column, the color should vary across this one. The next label, Y label. Okay. So if I run that particular thing, then you can see here the plot is there. Okay. So this will be the plot. So here also you can see, instead of a confusion matrix, okay, there also you can see like it's coming like this. Misclassifications are there. So setosa, some are like misclassified as 1, right? Versicolor also, some are like this and one have been misclassified like this. This you have seen earlier also when we have seen the different types, right? Some misclassification has come, right? So right now we have just considered only 2. Now we can see anyway. Now we can see that how this. So this program I'll upload. Just run this one and see what is the problem with the confusion matrix. Okay. Now I'll show you with the 3 different types. Okay. Ever considering everything. So what I'll do is like I'll clear everything from the environment as well as the workspace. Okay. So yeah. So again the same library, all the rest of the things I'll just run together since I had already mentioned about that. So just I'll minimize this one. Okay, minimizing the console and the levels, null values, everything, yes. So right now I'm just putting like set seed is 100, sample I'm giving like 1 to 50, 120. Okay, you can use this method also for splitting. Okay, or like what we have done earlier, I'm using like this. Okay, so set seed, then I'm just giving like, so this is like 80-20 splitting. Okay, 80 percentage training and the other as testing. Okay, so this one right now it will come like, so many plots are there. Sorry, I'll remove. Everyone that has been already present. Okay, let it be there. So these dimensions right now have come like 125 and 35. Okay. Okay. So just a pair plot once again with all the things, because right now, yeah. So right now, I haven't splitted it. Okay. Here I had like splitted. Just taken the sepal length. Okay. So what will be doing is like, I'll consider the pair plot with everything and we'll see how it looks like. So right now everything else is there. Okay, so this is the maximum that we can do. Let me see, this is the maximum that we can do. Somebody is sending some reactions. Okay, so these are the three classes present. Okay, so when we were having just the two classes, you could see like it can be separated. Okay, anyway, the graphs will look like normalized only. That's the same cases like earlier, but the box plot is showing that you can't separate these two. Okay, there is no case in which you can separate these two. Okay, if you look at the petal length, there is some little possibility, right? Petal width also has some possibility. So earlier when you had seen, you can just seen like petal width, petal length, and have some kind of significance, right? So like this also you can find out from the distribution. So they are separable, right? Now, so this is a complete pair plot of all containing all the different things. So I'll just go back. Okay. So now what we'll do is like we will put everything. Okay. Like for example, the depend variable is there, species, and I'll have all the this dot represent that we are considering all the variables. And right now, if what is your problem, Jishnu? You can unmute yourself and tell. Okay, so I'm just putting like the logistic regression model with this one. So I have just got the summary. So right now, if you are considering everything, it's coming like this. Okay. Earlier, when you had done, so in your earlier case, when you had done, the thing was coming like, so I'll run everything till now. So it's like the pair plot, everything, and you were getting like this. Okay, when you have got the model, you are getting like significance like this, and then you are doing like this. So, but when you are considering everything, I'll just put this, I'll not plot the plot once again. So I'll run this again. So it's coming like in this way actually. Okay, when you're considering everything and every other thing, so there is, it's coming like this. Okay.
Stylish Sikandar model. Stylish Sikandar model, madam.
Okay. So you can see the difference here. What has happened? Okay. So where was I? Yeah. Summary is coming in this way. Okay. So there is like this p value, the prediction value is coming as like 1. Okay, and there is no quotes here also, so it's like you don't have to use every one of these values in this particular data set. Okay, for this particular model. Now we just see how the prediction looks like. Okay, like the earlier case. So it's like coming like this. Okay, predicted value, and for this one, so right now I'm checking the test value. Just see that in the difference here from our earlier case, like normal case which we had seen, we had just given the splitting ratio as 70 and 30. So in that like that, when we have given, it had come like 105 and the rest is tested. But in this particular example, when we have considered all the columns and the splitting rate is 80 and 20 as test set, we're getting a very poor model. Okay, and the predicted thing is like everything is coming like this. Okay, some are like 1, some are like 0. Okay, so it's difficult to see, right? And if you do a similar thing, like if you plot it, what you'll be getting, we will just see. So right now this is coming like in this way actually. Okay, there is no particular thing where you can tell it like this is this particular thing, this is the other thing. Okay, so here also when column equal to prediction. Okay, 2. So right now there is one particular thing that I have missed to do. So it's like wait, yeah, it's not 2, that is why. So the prediction with respect to, earlier we had only these 3 things actually, right? Where was it? So that's why we had given the q plot as 1, but here it's like length, width, petal length, and petal width, many other. So it's like 1, 1, 2, 2, 3, 4, 1 to 4 if you give, and round of prediction. So 1, 2, 3, 4, 5, and 6 is the prediction, and then the other one, this should be like the 5th. And then if you're giving the label, okay, so the label is like, it's not sepal length, it's like we can just give like the independent features. So if, okay, we will see what happens in this particular case. Okay, so it's like, oh, many errors are coming here. Okay, so here it's like first the prediction we are giving like 1 to 4. Okay, so just just put 1 itself and see with respect to the thing. So here with respect, so it's not like independent features, it's first column is like sepal length only. Okay, we can just try with different things later. So the q plot, it's coming like this one. So here you can see it's not a good model, right? Because Setosa, yeah, the prediction is right, that is fine. But for the other things, both these things are coming as one value, right? Now, if you see with respect to the next one, the next thing is like label label sepal width. Okay, sepal width we'll do with the petal length actually. We'll see how they are separated. For petal length, it's like petal length is 3. Yes. So if you do this particular thing, then it's coming like this petal length this much and all this data here. Okay, so yeah, there is difference here, right? You can see from the figure versicolor is, the predictions are coming like that, but still with the petal length you can just separate them, right? Some separation is there, right? Now, so that was what you had seen like the significance level earlier when you had run your model like this one. And let me run everything. Okay, so the plot also had used. Okay, yeah, sorry, I didn't have to run everything, just this much. Yeah, so like you have seen like petal length, petal width, and the intercept, they are having some significance. So if you, that's why when we had run like that, it was showing some difference for the petal length. Okay, so I think we have just seen the different variations here. I'll be uploading this, and find the variations and the errors in the thing and try to correct it, right? Okay, next class we will see. I'll give you the answer. Okay, so I hope it's clear till now. Do you have any other doubts? Okay, I hope everyone's clear. Okay, I'll be uploading this. Just see the different variations that you can check with the program and just see the different errors. Try to correct them. Okay, next class I'll be telling you. Okay, I'll be uploading these things. Okay, so I hope I have covered everything for this week's assignment, and these assignments will be similar. Anything else is there? You just inform me right now. So yeah, okay, I think it's clear for everyone. So we'll end the session right now. Okay, everyone have, I have one doubt. Yeah, tell me. One old doubt. Okay, of. Yes, I have asked this to the thing. They haven't replied till now. Okay, so as soon as I get a reply, I'll inform you. I have asked this question, right? Okay. You can also ask this in that forum. Actually, ask a question, right? You can also ask there. So someone there might be replying you. I have also asked them, but I haven't still got the reply. Okay. Yeah. Okay. So if anything else is there. Okay, I think I hope the session was clear for everyone. I'll be uploading these things. Whatever errors you try to see how to change it, okay? Yes, because there is some problem in that. Hmm? So try to do that and I'll mention the answer next class, okay? So thank you everyone. Have a nice rest of the day. Okay? Bye.